In this video I will start a ledge climbing system. This part will cover hanging on the ledge and climbing up. The player will hang on ledges that can be reached by pressing space. If you press W, then the player will climb up if there is space. This system also covers feet placement, so if there is not a surface to place feet on, then different animations are used instead of braced ones. The animation for transitioning to hang is also selected based on this. Finally, there is a hand-eye system so the player holds the ledge correctly. First we need to get the animations. I will be using Mixamo ones, but you can use other ones if you have better ones for Unreal Engine. The first animation is this idle to braced hang. Make sure to download it without skin. Next download this hanging idle animation. Next I will get this hanging idle animation with the legs hanging down. Then get braced hang to crouch. This is for climbing up. And finally get stand to free hang. This is optional as I will not be using this and instead modify the idle to braced hang to be similar to this since the heights and lengths will be the same. I will now use this Mixamo converter to convert from Mixamo to Unreal Rig. Make sure to press custom root motion for all animations and set frame, height, and rotation to 0, then press confirm. I will put a link to the software in the description. Now open Unreal Engine. I will make a new folder for ledge climbing. Import the animations. Rename the hanging idle animation so one says braced. Make different folders for each type of animation. Now open the player blueprint. I will need to modify the vaulting section as the system will also use the space key. Create a new custom event called ledge climb input. You can skip this part if you did not follow along with the vaulting tutorial from an earlier episode in the series. If not, then open the vaulting code. Replace the jump node here with the custom event we just created. Add a branch node. Make a new Boolean variable called isOnLedge for the condition. Now create a new function called ledgeTrace. There will be 3 float inputs. The first is an initial offset value. The second and third is how much to trace forward and up. There will be one Boolean output which checks if a climbable ledge was detected. There will be 2 vector outputs. These will be for the wall location and wall normal. Add a for loop with break. Set the first index to 1 and the last index to 10. Add a sphere trace by channel. We will be doing multiple traces to check the height of the wall. Get the actor location and add a vector to it. Split the pin. Multiply the loop index by the trace vertical input. Add this to the initial Z offset input. Connect it to Z. This will be the trace start. Add a vector to this for the trace end. Get the actor forward vector and multiply it by the trace forward input. Set the radius to 10. I will set the draw debug type as an input so it is easier to debug while testing. Add a branch node with return value as the condition. This checks if a wall was hit. Add another sphere trace. This trace is to trace for the ledge top location. Break the hit result of the first trace and set impact point as the end. Add 20 in Z to the impact point and set it as the start. This is so we trace from upwards. Now add a branch node. Drag out of return value and add the N operator. Break the hit result, and get the NOT operator of initial overlap. Connect this to the second condition of the N node. This is the branches condition. Then add a sequence and connect the first path to break from the for loop. For the second path add a return node. Set ledge detected to true. The location output will be the impact point of the second trace. The normal output will be the impact normal of the first trace. This is since we need the normal from the player to the wall and not the vertical trace one. Connect the return node after completed of the for loop. This is since if it completes, it means that all traces did not find a ledge since the for loop breaks if one was. Make sure to set the radius of the second trace as well. I will now comment the function. Add the trace ledge function to false of this branch. Get is falling to check if the player is grounded or not since the trace lengths should be different if falling. Add a select float for the initial Z offset with the condition as is falling. Trace forward will be 100. Add a select for trace vertical as well. You can use the same values as I am or change them to your liking based on tests. As you can see, the trace is working and it stops tracing if a ledge is detected. Add a branch node with ledge detected as the condition, and if false, then jump. The trace is different if the player is falling. Make a new macro called hang on ledge. There will be two vector inputs for the location and normal of the ledge. Add the can move variable and connect it to inputs. This variable was made in an earlier episode and just controls if we can move by adding a branch before adding movement input. Now add a set timer by function name. Make a new custom event called check if ledge has surface. This will trace if both feet has a surface to be placed on. Copy and paste the event's name into the function name of the set timer. Set the time to 0.01 and looping to true. For the custom event, add a sequence node. Then add a line trace by channel. You can copy these nodes for the start and end locations. The values used can be changed if it doesn't work as precisely for you. Duplicate the line trace for then 1. Promote the return value of each trace to a variable for each surface. Now create an animation montage of idle to braced hang. Open the animation and enable root motion and set force root lock to true. The root bone also moves up. Now open the montage again. You have to have motion warping enabled for the system, which is a built-in plugin. Add a motion warping notify state. Set it to last for the whole animation. Set the warp target name to hang position. Disable ignore Z-axis. The idle to free hang animation is not aligned with the idle to braced hang, as you can see. So I will delete the to free hang one and modify the to braced one to mimic free hanging. You can modify animations by transforming the bone and pressing Add key at the top. I will finish it off camera. This is the final result. Create an anim montage of this as well. Copy and paste the warp motion notify over to the free hang montage. Now go back to the player blueprint. Subtract a vector from the ledge location and split the pin. Get the scaled half height of the capsule component and add 100 to it for Z. Then make a rod from X of the normal and get forward vector of it. Multiply this and add it to the subtract vector. The value to multiply by will be 48. This means the player will move 48 units away from the wall. Next, break the make rod from X. Make a rotator from it with X and Y the same but subtracting 180 from Z. Now add a vector and add the half height to Z. Now add a move component to. The component will be the capsule component. The location will be the actor location. The rotation will be the make rotator. Set the overtime to 0.1 and force shortest rotation path to true. Next, add a branch node that checks if falling. If false, then set the movement mode to flying. Then add or update warp target from motion warping. You can add this component from the top left. The location will be this add vector. The rotation is the make rotator. Add a branch that checks if on ledge. Add it before the add or update warp target. Now play a montage. The montage will be a select node with ledge has surface left as the condition. If true, then play the braced one, if not then the freehang one. Then set is on ledge to true. If the branch was true, then add a move component too. This is for later episodes as we will need to rehang onto the wall once we rotate around corners or hop between ledges. Set the location to this add vector. The rotation will again be the make rotator. If falling, then connect straight to the move component too. On completed, set the movement mode to flying. Connect this to set is on ledge to true. I will now comment the macro. Add the macro and connect it to true from this branch. The inputs will be the vector outputs of the ledge trace function. I will modify this value in the select node as well. Open both hanging idle animations and enable root motion for them. You need to make sure the animation blueprint takes root motion from everything and not just montages. Now go back to the hang on ledge macro. Add a stop movement immediately. Connect is on ledge to it. As you can see, the player now jumps up to the ledge and stays in air. Open the animation blueprint. Promote is on ledge and the to ledge has surface variables in the animation blueprint. Then make two float variables for the alpha value of each foot on surface. For the left foot alpha, get AF interp 2 as the value. The current will be the left foot alpha. The target will be not of the ledge has surface L boolean. Convert this boolean to a float. Value of 0 means false and 1 means true. Delta time is the world delta seconds. Set the interp speed to 4, but you can adjust this if you want. Duplicate this for the right foot alpha as well. Add a new state machine in the anim graph and name it ledge movement. Save this into a new save cached pose. Open the state machine. Now add a new state called hanging idle. We will now dynamically select between braced or free hanging based on if there is a surface or not. Add the braced hanging idle and set it to looping. Then get a blend poses by bool. The condition will be both ledge has surface variables, since if both do then we just play the whole braced hanging. I will reduce the blend times to 0.1. If false, then add a layered blend per bone. This node allows us to layer an animation on certain parts of the skeleton. Add a new branch filter and set the bone name to thigh_R. Enable both mesh space rotation blend and mesh space scale blend. These are to make it smoother. Add hanging idle for blend pose 0 and set it to looping. The blend weight will be the right foot alpha. The base pose will be the exact same but for the left foot, so replace the bone name to thigh_L. Before slot default slot add a blend poses by bool. If true, it will play the ledge saved pose, if not then main state. The condition will be is on ledge. Close and reopen the animation blueprint. Scroll down in the right and here you can set the root motion from everything option. I will set the capsule component to be visible so it is easier to see if the system is working properly. The hanging is sort of working but it is quite buggy, so let's fix that. First we need to set the name in this make motion warp target from the hang on ledge macro. Set it to be the same as the name of the motion warping montage notify which was hang position. This makes it less buggy but there is still some. Rearrange these nodes. Now the bugs are mostly fixed. I will fix the rest after doing the climb up system. I will use the W key to climb up the ledge. Add a branch that checks if on ledge. Then do a capsule trace by channel. This will check if there is anything blocking the way. Copy these nodes for the start and end. It is similar to the code we have used for previous traces in the system. Set the radius to 25 and height to 80. Drag out of return value and add a branch to check if anything was hit. If false, then set is on ledge to false. Then set actor enable collision to false. Add a sequence. The first path will be a line trace by channel. The second will have a delay of length 0.8. Set the movement mode to falling after this. Set the start of the line trace as the same location from the previous capsule trace. Subtract 100 in Z from it for the end. Add a sequence after it. Then add a move component to for the capsule component. The location will be the world location of the capsule component with 20 added to Z. The rotation will be the capsule's world rotation. Set force shortest rotation path to true. On completed, set the actor collision back to enabled. Add a reroute node from then 1 in the sequence. Now open the braced hang to crouch animation. Enable root motion on it and set force root lock to true. Now create an animation montage of it by right-clicking and pressing Create Anim Montage. Add a motion warping notify for the whole montage. Set its name to climb position. Uncheck Ignore Z-axis. Add an add or update warp target. Break the hit result of the line trace. Set the name to climb position. The location will be the hit result location with 10 added in Z. The rotation will be the actor rotation. Then set can move to true. Play a montage from the mesh and set it to the hang to crouch montage. I will change the draw debug types. The climbing mechanic works. As you can see, there is an error when hanging onto different sized walls. This is because of the foot IK system. Go to the animation blueprint. For the should do IK trace condition, we will add another condition. Use an operator. The second condition will be not of is on ledge. Now it is hanging correctly. Create a new boolean that overrides the foot IK. Set it to true after the set timer in the hang on ledge macro. Promote the variable in the animation blueprint. Now use a select node for the foot IK control rig alpha. If the override variable is true, then it is 0, otherwise 1. The hanging works now on both different height walls. I will now demonstrate on a wall without a surface for the feet. As you can see, the animation is different and the player is free hanging. Now make a new custom event called Ledge Hand IK. Make a new function to find the hand IK locations. Add a sphere trace by channel. Copy these nodes for the start and end. Make this multiply value an input, Set the radius to 15. I will make the draw debug type an input as well. Now break the hit result. Add a branch with return value as the condition. Next add a set vector by ref node. The value will be the hit result's location and the target will be a new input. Add a return node after it. Add a Boolean output called hit. Set it to true. Add another return node if the branch is false and the output is false. Add the function in the custom event. Promote the target to a variable called left-hand IK location. The offset will be -25. Duplicate the function for the right-hand IK as well. Now make a new float variable called hand IK target alpha. If both the function's outputs are false, then set the target alpha to 0. Go to the hand on ledge macro. Set the alpha to 1 after stop movement immediately. Now add a set timer by function name. Set the time to 0.01 and looping to true. The name will be the name of the hand IK custom event. Promote the return value to a variable called ledge IK handle. Make sure you change the offset value for the right hand. Go to the animation blueprint. Promote both hand IK locations to a variable. Also promote the hand IK target alpha. Replace the value of it with an f-interp2. Copy the setup. Add 2 bone IK nodes after the ledge state machine. Set both alphas to the hand IK target alpha. The first joint target location will be the hand IK left location and the second will be the right one. Select the first 2 bone IK and set the IK bone to hand_L. Set the second one's bone to hand_R. Now select both two bone IK nodes. Set effector location space to world space and joint target to parent bone space. This is since the hand IK location will change based on where the player is. Set the joint target for each to the respective upper arms. I will set is on ledge to true to debug the two bone IK values. Change the values if it doesn't look right for you. I will adjust some of the values used in the system. You can copy them if you like and then make any changes if you need to. The hand IK is now working. Go to this part in the climb up code. Add a branch that checks if the IK handle is valid, and if it is then clear the timer before continuing the code. If false, then just continue the code. Go back to hang on ledge. Add a short delay before setting is on ledge to true. I will use a value of 0.1 for the delay. Add a clear timer by function name in the sequence. The function name will be the name of the custom event for checking ledge surfaces. The system now works correctly. I will refine this in the upcoming episodes. The next episode will show how to add moving left and right on ledges and exiting the ledge. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.